Good, let me do that. I know some of this I did do last time, but I feel better going through it again. All right, so in this section, 1.2, I mean, it's not that long, so might even finish it today. All right, so here what we're going to see is what a quadratic equation is. We're going to see what a quadratic equation is, and we're going to see two ways of solving quadratic equations. One of them will involve factoring, so we're going to see how we can use factoring to solve quadratic equations. And we can also solve quadratic equations using the quadratic formula. Okay, so again, we're going to see what a quadratic equation is, and we're going to learn two methods for solving it. There are more methods actually, and one of them is called the square root method. The book covers it, but for time consideration, I'm only going to focus on these two. Okay, the factoring method and solving it using the quadratic formula. All right. Okay, so I know I did present this last time, but I feel better going through it again. So a quadratic equation, what is it? Well, remember in 1.1 we saw some vocabulary with equations, like solution, what is an equation, terms, that kind of stuff. A quadratic equation in the variable x, by definition, it's an equation that can be written this way. Can be written this way means it's an equation that's equivalent to this. So you could do manipulations on the equation you're given, the ones we saw in the previous section, 1.1, and you can end up with this equation. You have a quadratic, that is a polynomial of degree 2 on the left side, and on the right side, you have 0. Where A, B, and C here, those coefficients, where A, B, and C are numbers, A, though, cannot be 0. I mean, if A were 0, we'd be back in the previous section, but we're done with that, okay? In fact, the form we have here, this is what they call the standard form. You have the polynomial of degree 2 on the left, and you have 0 on the right side. So that's what we have here. In fact, what's nice about these equations is that you can only have at most 2 real solutions. Remember, linear equations, right? Linear equations, if you remember, they only had one solution. Well, they can only have at most one solution. With a quadratic equation, though, you can have no more than 2 real solutions. It actually turns out, by the fundamental theorem of algebra, that they're always going to have at least one complex solution. But since we're not dealing with complex numbers, we do have the possibility then of having no solutions. But you can't have more than 2 real solutions. That's impossible. And again, we have 2 different ways of solving them. What we have is factoring, and we have the quadratic formula, which we're going to see shortly. Okay, and again, we're only focusing on real solutions here. All right. I'm going to demonstrate how you solve it by factoring. Then I'll show you the procedure. I did email the notes to everyone, just letting you know. So let's say we have this equation we want to solve, and we're going to solve it by factoring. We have actually seen this before. Well, we have actually factored this before. Notice that we have a polynomial of degree 2. There's 3 terms here, so it's a trinomial, and the leading coefficient here is 1. The leading coefficient here, notice, is also 1. So how do we factor this? We want 2 integers whose product is 10, the constant term, and whose sum is 7. Okay, so we want two integers whose product is the constant term and whose sum is the coefficient of x. So in this case, we want two integers whose product is 10 and the sum is 7. Well, 5 and 2 are going to pull that off, right? 5 and 2 we know are two numbers whose product is 10 and whose sum is 7. So we have those two numbers. What do? We have the factorization, right? We have our polynomial. We can write it as x plus 5 times x plus 2. Okay, so this was equal to 0. What does that tell us? Well, since this is equal to this, we must have this product equal to 0. Notice we can't factor any further, right? Now, what's nice is this. If you have a product equal to 0, then at least one of the factors here must equal 0. So from here, in other words, we can conclude that this equation must be true, or this equation must be true. So to get all possible solutions, we're going to solve this equation and this equation. And these equations are a lot easier, right? Essentially, by factoring, we essentially eliminated an x squared term. Okay, so we're going to solve this. We're going to solve this equation. This one's not so hard, right? What do? You want to get x all alone, so we subtract 5 from each side. So we get x equals -5. So -5 is a solution. From here, we have x plus 2 equal to 0, as you can see, right? And so what do? Again, we subtract 2 from each side. So by subtracting 2 from each side, we get x equals -2. So again, from this equation, let me say it again. We want x all alone, right? So let's get the 2 out of there. We subtract 2 from each side. And doing so, we get x equals -2. Like so. Okay, that's good. That's what we get here. Okay, so we have two solutions. And again, there can't be any more solutions because our polynomial was degree 2. And it's good to check, and that's what I do also. As a check, we just substitute and see that we get the solutions. We see that these are solutions. All right. Okay, that's good. So we are correct. Okay, so we just solved a quadratic equation by factoring. Now, what procedure did we follow? We did this one. It was already in standard form. Normally, you have to convert it to standard form. And essentially, that just means you get the right-hand side equal to 0. That's really what it boils down to. That's what the first step is. You factor the left-hand side completely, meaning you factor until you can't factor anymore. Then what do? Just like we did, you set each factor equal to 0, okay? And you solve the resulting equations. From each factor, what's going to happen is you're going to get an equation, and from each equation, you can get a solution. I mean, you'll see not every factor can give you a solution. You still should set each factor equal to 0, though. And of course, it's good to check your results. Okay, so before we do some examples, are there any questions? Or what questions do you have? That's better. Okay. Okay, well, let's do some examples, but first I got to pause the recording.